In this video, I'm going to show you how to use this decision tree. Now, decision tree, the purpose of it is to help us understand which hypothesis test we are dealing with in a particular question or scenario. So you can see that this decision tree starts off by asking the first question of what am I dealing with, means or proportions? Once we have that, then you'll see boxes in the top left and in the top right. If you're dealing with means, you branch off to the left, so you use the box in the top left to check your central limit theorem. And those are the two conditions needed to satisfy the central limit theorem for quantitative problems. Now, if you're dealing with proportions, then you branch off to the right. You'll use the top right box and use those conditions to satisfy the central limit theorem. Either way, our second question, that's our stop there, is the central limit theorem satisfied? So first thing we do is find out, are we dealing with quantitative data, means and standard deviations and all that? Or are we dealing with proportions, fractions and percentages and so on? Once we do that, we check the central limit theorem. Then, if we're dealing with quantitative data, the next question is, do we have a population standard deviation? So this is only if we're dealing with means. Do we know population standard deviation? If we do, if yes, we use a z-score. But if no, we use a t-score. Okay. If we are given the standard deviation for our population, we take this branch to the left and we say we're going to be using a z-score. If we have a if we do not have a population standard deviation, then we take the branch to the right and we know we're going to use our t-score. Our fourth question that we need to ask is, do we have one sample or two samples? If we only have one sample, then it doesn't matter if it's Z or T. You take the left branch, one sample, you'll be using the Z interval for a confidence interval, or the Z test for a hypothesis test. If you do the t-score with one sample, you'll use the t-interval function or a t-test for your confidence interval and hypothesis test. By the way, these are the functions that are written on your TI-84. So not only will this decision tree help us know which type of test we are dealing with, but it also helps us to know which function on the TI-84 to use. Okay, so once we know that, then we say, okay, we've answered those four questions. We know where we are on the table. We can decide which function to use. Let me show this to you with an example here. The Career Center at a small university track the length of time it takes. I'm sorry, I read that wrong. The Career Center at a small university tracks the length of time it takes graduates to find full-time jobs following graduation. Data from the past show that the mean time to find a job was normally distributed with an average of 5.5 months. A random sample of 24 recent graduates showed a sample mean of 7.2 months to find a job with a standard deviation of 3.1 months. Is the evidence strong enough to support the claim that the mean time to find a job is different than what it was in the past? Okay, so here's our first question. We start off, are we dealing with means or proportions? Take a look at the question. You'll see words like average or mean, or most poignantly, standard deviation. If you see standard deviation, that's an automatic tell that we're dealing with means. Okay, from here, we take a little side trip and we say, is the central limit theorem satisfied? Well, what is sorry, the first one is, what is our sample size? A random sample of 24 recent graduates. So we have 24 graduates. Our sample size is 24. That's not large enough. It needs to be at least 30. However, remember that we have a second condition. Population can be normal. So let's take a look in here. Sure enough, one line above that, we see data from the past show that the mean time to find a job was normally distributed. And so, yes, that checks. The second condition is that it's a random sample. Yes, it is. It just says so right there. So central limit theorem is satisfied. Now we go to our next question. Do we know a population standard deviation? Well, if you go through this, we have an average of 5.5 months. That's the population mean. We have a sample mean of 7.2 months and a standard deviation of 3.1 months. What does this standard deviation describe? Is it describing the population or is it describing the sample? Well, it turns out this is describing the sample, right? It showed a sample mean of 7.2 months to find a job with a standard deviation of 3.1 months. So this is connected to the sample. The standard deviation is connected to the sample. There we go. Which means, no, we don't have a population standard deviation. That means we are going to be dealing with a t-score. Final question. Are we dealing with one sample or two samples? Well, we have one sample of, here's one sample of 24 recent graduates, and that's it. We're comparing the one sample to our null value. This will be our null value up here. We're comparing our one sample to the null value. So we're just dealing with one sample. So that means these are the functions we will be using on our calculator. Are we doing a confidence interval? If so, use the interval function. Are we doing a hypothesis test? If it's the hypothesis test, we use the t-test function. Turns out that this question is saying, is the evidence strong enough to support the claim that the mean time to find a job is different than what it was in the past? We're comparing what we have now to what we had in the past. This would be a hypothesis test. And so the function is a t-test. There you go. That is how to use this decision tree.